What if Mars had once been Earth's twin, and the two planets exchanged life long ago? What if I told you that the red, barren desert we call Mars today was once a blue marble, just like Earth? What if those two worlds, spinning in the cosmic dance around our sun, were once twin sisters, both teeming with oceans, forests, and life itself? And here's the part that might blow your mind. What if they didn't just share similar conditions, but actually shared life? What if ancient microbes, maybe even complex organisms, traveled between these worlds billions of years ago, seeding one another in the greatest exchange program the solar system has ever known? I'm your host, and today we're diving into one of the most fascinating mysteries in all of space science. It's a story that challenges everything we thought we knew about life, death, and rebirth on a planetary scale. It's a story about two worlds that might have been more connected than we ever imagined. Welcome to another episode of Javis Heist, where we explore the mysteries that keep scientists awake at night. Picture this. It's 4 billion years ago. Our solar system is young, violent, and very different from the peaceful neighborhood we know today. Asteroids, the size of mountains, hurtle through space like cosmic bullets. The planets are still settling into their orbits, still cooling down from their fiery births. But here's what's remarkable during this chaotic period. Both Earth and Mars were remarkably similar. Mars had a thick atmosphere, just like Earth. It had vast oceans that covered much of its northern hemisphere. It had weather systems, maybe even seasons. Some scientists believe it might have been even more hospitable to life than Earth was at the time. Now, I want you to imagine standing on the shore of an ancient Martian ocean. The water laps at your feet, yes, liquid water, warm and welcoming. The sky above you might have been blue, not the rusty red we see today. Clouds drift overhead. In the distance, you might see the massive volcanic peaks that we now call Olympus Mons and the Tharsis volcanoes. But they're active, spewing water vapor and gases that help maintain this thick, protective atmosphere. This isn't science fiction. This is what Mars likely looked like for hundreds of millions, maybe even billions of years. Meanwhile, back on Earth, life was just getting started. The first simple organisms were figuring out how to survive in a world that was nothing like the one we know. No oxygen to breathe, in fact. Oxygen was toxic to most early life forms. No green plants, no blue skies. Just primitive microbes learning the basic tricks of existence. But here's where it gets interesting, and where our story really begins. You see, Earth and Mars weren't just similar worlds developing in parallel. They were neighbors in the most literal sense, and in those early days, they were much closer together than they are now. And when you're neighbors in space during a period of heavy asteroid bombardment, things can get exchanged. Scientists call it panspermia, the idea that life can travel between planets. And I'm not talking about little green men in spaceships. I'm talking about microscopic hitchhikers, riding aboard chunks of rock blasted from one planet to another. Here's how it would work. A massive asteroid slams into, say, Mars. The impact is so violent that it literally blasts rocks, some as big as cars, others as small as pebbles, right off the planet and into space. These rocks, now called meteorites, go flying through the solar system, some of them, by chance and gravity and the complex dance of orbital mechanics, eventually crash land on Earth. Now, you might think, well, that's all well and good, but surely any life would be fried by the heat of impact, or killed by the radiation of space, or destroyed by the crash landing. And you'd be mostly right. But here's the thing about life, it's incredibly, almost impossibly resilient. Let me tell you about some of the toughest little survivors on our planet. There are microbes that live in boiling water around underwater volcanic vents, others that thrive in the frozen wasteland of Antarctica, where temperatures drop to 80 degrees below zero. Some bacteria can survive direct exposure to the vacuum of space for years. In 2007, European scientists sent a type of bacteria called Deinococcus radiodurans to the International Space Station. They exposed it to the harsh radiation and vacuum of space for 18 months. When they brought it back to Earth, guess what? It was still alive, still reproducing, still doing its bacterial thing as if nothing had happened. But even more remarkable are the experiments that simulate the exact conditions of interplanetary travel. Scientists have taken bacteria, frozen them inside chunks of rock, subjected them to the shock of impacts, exposed them to radiation, let them float in the cold vacuum of space for months or even years, then slammed them into targets at thousands of miles per hour to simulate landing. And some of them survive. Not many, but some. Now imagine this happening not once, but thousands of times over millions of years. Earth and Mars, engaged in this slow-motion game of catch, tossing rocks back and forth like cosmic baseballs. And sometimes, just sometimes, those rocks carry passengers. So here's where our story gets really interesting, and where science starts to read like a detective novel. We've found Martian rocks on Earth. Not many, but we found them. These meteorites have a very distinctive chemical signature that matches exactly what we see in the Martian soil and atmosphere today. They're like cosmic fingerprints, proving they came from Mars. But here's what's fascinating. Some of these Martian meteorites contain what look like fossils, microscopic structures that resemble bacteria, organic compounds that on Earth would almost certainly indicate life. The most famous is a meteorite called ALH 84001, found in Antarctica in 1984. When scientists sliced it open and looked at it under powerful microscopes, they found tiny worm-like structures that looked remarkably similar to bacteria fossils found in ancient Earth rocks. The scientific community went crazy. Some researchers were convinced they were looking at evidence of ancient Martian life. Others argued these structures could have formed through purely chemical processes, no life required. The debate rages on today, more than 30 years later, but here's what everyone agrees on. These rocks definitely came from Mars. They're definitely very, very old. We're talking billions of years. And they definitely contain organic compounds that are associated with life. Now, here's the question that keeps me up at night. If life could travel from Mars to Earth in these rocks, what about the other direction? Could life have traveled from Earth to Mars? Think about it this way. Early Earth was a bustling hub of biological innovation. Life was figuring out photosynthesis, learning to use energy from the sun, developing all the basic biochemical tricks that life still uses today. It was like the biological equivalent of Silicon Valley, a hotbed of innovation and development. Mars, meanwhile, was this beautiful world with oceans and atmosphere, but maybe it was a little slower to develop life on its own. Maybe it needed a head start. What if some of Earth's early life forms made the journey to Mars aboard Earth meteorites blasted into space by asteroid impacts? What if they landed in those warm Martian oceans and thought, "Hey, this is nice. Let's set up shop here." This isn't just wild speculation. We know that rocks regularly travel from Earth to Mars, just as they travel from Mars to Earth. In fact, it's probably easier for Earth rocks to reach Mars than the other way around, because Earth is more massive and gets hit by more asteroids. And here's the kicker. During that early period, when both planets were warm and wet, the journey time between Earth and Mars would have been much shorter than it is today. We're talking maybe a few 100,000 years instead of millions. That's well within the survival time of some of the hardiest bacteria we know. So picture this cosmic exchange program. Earth develops life first, then shares it with Mars. Mars takes that life and runs with it, maybe developing it in slightly different directions because of the different environment. Then, Mars shares its innovations back with Earth. Back and forth, the two worlds seeding each other with life for millions of years. But then something went wrong, catastrophically wrong. Mars began to die. It happened gradually, over hundreds of millions of years, but from a planetary perspective, it was swift and final. Mars lost its magnetic field, the invisible shield that protects a planet from deadly solar radiation. Without that protection, the solar wind began stripping away Mars's atmosphere, molecule by molecule. As the atmosphere thinned, the temperature dropped. The oceans began to freeze, then evaporate into space. The weather systems shut down. The blue sky turned black. Then red as iron oxide rust began to dominate the landscape. The life that had flourished in those ancient oceans and rivers found itself in an increasingly hostile world. Some may have retreated underground, where we might still find it today, hiding in pockets of liquid water deep beneath the Martian surface. Others may have gone extinct entirely. But here's the haunting possibility. What if some of that Martian life, desperate to escape their dying world, made one final journey to Earth? What if the very life forms we see on Earth today, the bacteria in our oceans, the microbes in our soil, maybe even the earliest ancestors of complex life, what if some of them are actually Martian refugees, descendants of organisms that fled their dying planet billions of years ago? This is where our story enters the realm of modern detective work, because we're finding clues everywhere we look. Scientists have discovered that some of the most ancient life forms on Earth have biochemical signatures that are unusual, unexpected. They use chemical processes that seem almost designed for a different kind of world, a world with a different atmospheric composition, different temperatures, different conditions. For example, there are ancient bacteria that seem perfectly adapted to high levels of carbon dioxide, much higher than Earth's early atmosphere contained, but exactly what we'd expect from ancient Mars. There are microbes that thrive in extremely salty conditions, like the brines that we now know exist beneath the Martian ice caps. Others that seem designed for low-oxygen environments with high levels of methane conditions that would have existed on ancient Mars. And then there's the timing. Complex life on Earth took a remarkably long time to develop, then suddenly, in geological terms, exploded into incredible diversity. What if that explosion wasn't just Earth life finally figuring things out? What if it was the result of a massive infusion of Martian genetic material, bringing billions of years of evolutionary innovation from our sister planet? Here's where the story gets really mind-bending, and where modern genetic science becomes our detective tool. All life on Earth shares the same basic genetic code, DNA and RNA. But here's what's weird. That genetic code isn't the only possible code. In fact, scientists have calculated that there could be millions of different ways to encode genetic information, and the one life uses seems almost arbitrary. Unless it isn't arbitrary, unless all life on Earth uses the same genetic code because it all descended from the same source, a source that might not have originated on Earth at all. There's another clue hidden in our DNA. Scientists have found that some of the most fundamental genetic processes, the basic machinery that all life uses to reproduce and function, show signs of being much older than Earth's oldest rocks. It's as if life came to Earth already sophisticated, already complex, with billions of years of evolution already behind it. Where could that evolution have taken place? Maybe on a world that had a head start on Earth. A world like ancient Mars. And here's the part that gives me chills. Some scientists believe they've found genetic markers, specific sequences of DNA that appear in Earth life, but seem designed for conditions that never existed on Earth. Conditions that match perfectly with what we know about ancient Mars. But our story doesn't end with ancient history, because Mars might not be as dead as we think. In recent years, spacecraft orbiting Mars have detected something extraordinary: methane in the Martian atmosphere. Methane that appears and disappears in patterns that suggest it's being actively produced by something beneath the surface. On Earth, most atmospheric methane comes from living organisms. Bacteria, plants, animals' life produces methane as a byproduct of metabolism. Could the same thing be happening on Mars? Could there be a hidden biosphere deep beneath the frozen surface, descendants of the life that once swam in those ancient oceans? NASA's rovers have found other tantalizing clues. Organic molecules in Martian rocks, seasonal changes in atmospheric composition that suggest active processes below the surface. Subsurface formations that look remarkably like the structures formed by underground bacterial communities on Earth. And then there are the recurring slope-linear dark streaks that appear on Martian hillsides during the warmer seasons, then disappear when it gets cold. They look exactly like what you'd expect if liquid water was flowing just beneath the surface, carrying with it the chemical signatures of life. What if Mars isn't dead at all? What if it's just dormant? What if there's still life down there, waiting for conditions to improve, carrying on the biological legacy that began billions of years ago when it was Earth's twin? Now, I want you to think about what this means. Really think about it. If this theory is correct, if Earth and Mars really did share life, if we're all descended from organisms that traveled between worlds, then we're not alone in the universe. We never were. We're Martians. At least partly. The bacteria in your gut, the cells in your body, the very DNA that makes you who you are. Some of it might carry the legacy of a world that died billions of years ago. You might be the distant descendant of organisms that once swam in Martian seas, breathed Martian air, looked up at Martian skies. And if life could travel between Earth and Mars, what about other worlds? Europa, Jupiter's ice-covered moon, with its vast subsurface ocean. Enceladus, Saturn's small moon that shoots geysers of water into space. Titan, with its lakes of liquid methane. What if the entire solar system is connected by this invisible web of life, with organisms traveling between worlds on the slow cargo ships of asteroid impacts and gravitational encounters? What if life isn't rare at all, but is instead the natural state of the universe, constantly moving, adapting, finding new homes among the stars? This possibility has fundamentally changed how we search for life in the universe. NASA's current Mars missions aren't just looking for evidence of ancient life. They're looking for life that might still be there. The Perseverance rover is collecting rock samples that will eventually be brought back to Earth, where we can analyze them with the most sophisticated equipment we have. We're looking for biosignatures, chemical and physical evidence that can only be created by living organisms. And we're preparing for something that seemed like science fiction just a few decades ago: human missions to Mars. When the first astronauts land on the red planet, probably sometime in the 2030s, one of their primary missions will be to search for life. But here's the twist that keeps scientists up at night. What if we find life on Mars, and it turns out to be related to Earth life? How will we know if it originated on Mars and traveled to Earth, or originated on Earth and traveled to Mars? How will we untangle billions of years of possible cross-contamination? And here's an even more unsettling possibility. What if we've already contaminated Mars with Earth life? Every spacecraft we've sent there, despite our best sterilization efforts, might have carried microbial stowaways. What if the life we eventually find on Mars isn't ancient Martian life, but descendants of Earth bacteria that hitchhiked on our robots? This isn't just a scientific question, it's a philosophical earthquake that challenges our most basic assumptions about who we are and where we come from. For thousands of years, humans have told stories about our origins. We've looked up at the stars and wondered if we're alone. We've created mythologies and religions and scientific theories to explain our place in the universe. But what if the answer was right there next door all along? What if we're not alone because we never were alone, because we're part of a family of worlds that has been sharing life for billions of years? Think about how this changes our relationship with Mars. It's not just a distant alien world anymore. It might be our ancestral home, or at least the home of some of our ancestral organisms. When we look up at that red dot in the night sky, we might be looking at a planet that shares our deepest biological heritage. And if Mars really is still harboring life beneath its frozen surface, then it's not a dead world, it's a dormant world, waiting for the right conditions to bloom again. Some scientists have proposed that we could help wake Mars up. We could thicken its atmosphere, warm its surface, maybe even restore its magnetic field using advanced technology. We could bring the red planet back to life, return it to the blue marble it once was. Is that playing God? Or is that just helping a sibling planet that fell on hard times? You know, when I first started researching this topic, I thought it was just another fascinating space science story. But the more I learned, the more personal it became. I started thinking about my own ancestry. Like most people, I can trace my family history back a few generations, maybe a few centuries if I'm lucky. But what if I could trace it back billions of years to organisms that lived on another planet entirely? What if the reason I feel drawn to look up at the night sky, the reason we all feel that sense of wonder when we contemplate the cosmos, isn't just curiosity? What if it's homesickness? What if some part of us remembers, on a cellular level, what it was like to live under alien skies? I think about the dreams that humans have always had about traveling to Mars, about making it our second home. What if those dreams aren't about conquest or exploration, but about return? What if we're not trying to colonize Mars, but to come home to Mars? And I think about the incredible resilience of life, the way it survives ice ages and asteroid impacts and mass extinctions, the way it adapts and evolves and finds ways to thrive in the most impossible conditions. If life really has been traveling between worlds for billions of years, then it's not just resilient, it's cosmically resilient. It's not bound by the limitations of a single planet or a single solar system. It's a force that operates on the scale of galaxies and geological time. We might not just be citizens of Earth, we might be citizens of the cosmos. But here's what keeps me humble about this whole story. We don't know. Not for sure. Not yet. The evidence is tantalizing, suggestive, compelling, but it's not conclusive. Every piece of potential proof has alternative explanations. Every exciting discovery is followed by years of debate and analysis and reinterpretation. Maybe those microscopic structures in Martian meteorites really are fossilized bacteria from an ancient Martian biosphere, or maybe they're just mineral formations that happen to look biological. Maybe the unusual biochemistry of some Earth organisms really does point to a Martian origin. Or maybe life is just more creative than we give it credit for, finding unexpected solutions to the challenges of existence. Maybe Mars really is harboring a hidden biosphere that could tell us the story of how life moves between worlds. Or maybe those methane emissions and organic molecules have purely geological explanations. The truth is, we're still in the early chapters of this story. We're still gathering evidence, still developing the technology we need to answer these questions definitively. But isn't that what makes it so exciting? We're living through one of the greatest detective stories in the history of science. We're the generation that might finally answer the question of whether we're alone in the universe, and the answer might be that we never were alone because the universe itself is alive. So, where does this leave us? What do we do with this possibility that we might be part Martian? First, we keep exploring. Every mission to Mars brings us closer to the truth. Every rock sample, every atmospheric measurement, every photograph of the Martian surface adds another piece to the puzzle. Second, we keep an open mind. The universe has a habit of being stranger and more wonderful than we expect. The idea that life regularly travels between worlds seemed absurd just a few decades ago. Now it's a serious scientific hypothesis being studied by some of the brightest minds on Earth. Third, we remember that we're part of something larger than ourselves. Whether or not we're descended from Martian organisms, we're definitely part of a cosmic story that spans billions of years and countless worlds. And finally, we appreciate the incredible, improbable, magnificent fact that we exist at all. That in a universe of empty space and dead rocks, we're here thinking, questioning, exploring, dreaming. We're stardust that learned to wonder about its origins. We're cosmic accident that became conscious. We're the universe's way of understanding itself. And if we're also Martians, if some part of us carries the legacy of a world that died billions of years ago, then we're something even more remarkable. We're proof that life finds a way. We're evidence that death isn't final, that worlds can die but leave descendants among the stars. We're the children of two worlds, citizens of the cosmos, inheritors of a story that began in the earliest days of the solar system and continues with every breath we take. As I wrap up today's journey through this cosmic mystery, I find myself looking up at the night sky differently. That red dot hanging there among the stars isn't just Mars anymore. It might be family. The story of Earth and Mars, of life traveling between worlds, of ancient oceans on distant planets, it's not just a scientific puzzle. It's a reminder that we're part of something vast and ancient and ongoing. We're chapters in a story that began billions of years ago and will continue long after we're gone. And maybe, just maybe, we'll be the generation that finally proves we're not alone. Not because we find little green men, but because we discover that we never were alone, because life itself is a cosmic citizen, traveling between worlds, adapting, surviving, thriving. The next time you see Mars in the night sky, wave hello. You might be waving to your ancestral home. What do you think? Does this theory resonate with you? Have you ever felt that strange pull when you look up at Mars? That sense of connection to something vast and ancient? I'd love to hear your thoughts in the comments below. And if you enjoyed this deep dive into one of science's most fascinating mysteries, make sure to subscribe to Javis Heist and hit that notification bell. We'll be back next week with another story that challenges everything you thought you knew about our world and our universe. Until then, keep looking up, keep questioning, keep wondering. Because in a universe full of mysteries, we're the lucky ones who get to be curious about them. Thanks for joining me on this journey through the cosmos. This has been Javis Heist, and I'll see you among the stars.